So, we've already discussed the history of hazardous materials in the environment and how it how it led to the creation of different environmental rules for handling. Once it reached that point, I always say that, some people usually have to die before our standards come into place. So we understand the creation of these different acts and why they're in place, at least generally. And as we move forward, there's three main classification systems. There's the Department of Transportation, there's the National Fire and Protection Administration Association, NFPA, and then there's also, of course, OSHA, the Department of Labor. So we're going to start with the Department of Transportation classification. And I always say that it's kind of like hidden here. What's actually rolling down the road? So what is 1993 or 1268 or 3082? And so usually what I would do in a class, if we were all together, is I just pause and have you guys think about what the differences that you see here. And if I pull this down, you can't pull it down. Well, okay, so I will not spare you of any more time. But a 3 is a liquid, so this is a flammable liquid, 1993. I want to look that one up. 9 is miscellaneous, and miscellaneous looks like this, kind of like a circus hat, 3082. We'll look that one up too. Now, easy, number 8 is a corrosive, 1824, so it's either an acid or a base. And then this one is hard to see. I'm sorry I cut that off, but it's 1268, and it's a 2 instead of a 3, meaning it's a gas instead of a liquid. And so this is the way that hazardous materials are easily identified by a number of people at the so easily. It's just so easy. So here, if we go to... So when you want to look up a hazardous material, you go to the site CAMEO, cameochemicals.noaa.gov, and this is pretty much the shopping mart of all chemicals. So it brings things together, such as the Department of Transportation and Global Harmonization System and NFPA. So you see that I've searched 1999. I made a mistake there. We were actually looking up 1993, so let's look that one up. We don't know the name. We don't know the CAS. But you may know the CAS. Okay, so this came up... combustible liquids not otherwise specified, compounds, tree or weed killing, which are flammable, or cleaning compounds. It could also be diesel fuel, flammable liquids not otherwise specified, and fuel oil. And so if you clicked on the data sheets, you'd see that all the proper name agents that can be associated with that one UN number 1993 are listed here, and it's probably a hydrocarbon of some kind, flammable liquid. And so that is the introduction to DoT, Department of Transportation. Okay, so also remember to keep up on the reading. Hopefully everything will be squared away soon. So in the text, chapter 11 which covers Department of Transportation, and if we do both, and the Global Harmonization System, that would be Chapter 11 as well. And I've also updated the homework. Don't worry about any due dates until the class is squared away, and I can deliver it different ways, whichever works great for us. But recorded seems to work well, so moving on here. All right. So our objectives for this learning unit is to understand that there are 9 different categories which Department of Transportation uses to classify hazardous materials. And wait, I'm going to go get the book. So 49 CFR 173 is this big, large document. And so we're going to go through this, we're going to parse it apart and look at the important parts. in general so that you can apply them to the specifics in your workplace. And anytime you want to ask me a question, please do so. I'm going to go here first, and you can find this online, but I love a paper version. And so the classification is found in 173, although other parts with packing and shipping are found in other areas, right? So the objective would be that you understand the different parts of a DoT placard, which is pretty straightforward, and that sometimes there's divisions and sometimes there isn't divisions. And so still today, most of our hazardous materials are transported over the land, over the highway, and they're of course transported in large amounts because that saves money, and the accidental release can cause can have massive effects for years on an environment or just immediately on a group of people. And it's some examples right here of hazardous materials incidents where people had actually lost their lives. And so part of this classification system is so that we could ensure that they're being packaged, shipped, and transported, and disposed of and stored of appropriately, as well as that all different levels of responders can respond immediately. So example, what does 1017 mean? And it's a 2, so immediately you could say, well, it's a gas, it's a poisonous gas. So it looks like it's a non-flammable poisonous gas that's also a corrosive and an inhalation hazard, and I know it's a compressed gas. So I know these by these placards, and these placards would have to be on anhydrous ammonia, the actual cylinder, or it wouldn't be labeled appropriately. So this is interesting because it's a inhalation hazard, and it's a corrosive.
Oh no. Oh. Watch out, watch out, watch out. Oh Lord. Oh, look at this truck. What do you think? You can't do anything. Somebody just lost so many people that died. Let's see if we can help people. Can you get out? Get out of your vehicle. Hurry up. Get out. You gotta get out. Everybody okay? Watch yourself.
Ooh, boy, that one gets me every time. All those different containers. So we had ones that were square, that had materials in them. Obviously, pyrophoric, because there were fireworks. Then there were flammable liquids of some kind. So it's, how do those responders know what's actually there? And it's these different marking systems, and it all begins with the Department of Transportation system in the big bad book. So it's estimated that over 500,000 shipments are made of chemicals, and I'm sure it's far greater than that. But 90% of them are by truck, and most of them are flammable and corrosive. And you have to remember this. So, flammable and corrosive liquids, these are the highest volume, and they're one of the most dangerous, especially if they're mixed together. So file that one away. 3 and 8, right? And so the title 49, it's just the chapter, just like it's titled 29 for Occupational Safety and Health Administration, or the Department of Labor regulations. But there's basically four key points. One of them is procedures and policies. So handling waste versus radioactive material. It would have your fines in there as well. And then we're going to really spend most of the class in these next two sections, which would be material labeling and packing requirements. And so you could see that there's many parts, and all these parts are in a big table, which makes it easy but yet slightly confusing. And so the Department of Transportation system is based on these 9 pictograms. So we got one for explosives, and those always have a subclass. I'm not covering them very much in this class. And then 2, we got our flammable gases. And then also at part of 2, and that's how there's a division, we have our non-flammable gases, as well as we have our toxic gases. That one just doesn't happen to be here. And then just oxygen itself. And that's listed yellow because oxygen is an oxidizer. So 2 is our gases, 3 is our flammable liquids. There's no other divisions with our flammable liquids. It's just all. Combustibles don't count anymore. That's the old way of doing things. And then 4, we have our flammables again, and these are our flammable solids. So flammable solids, and then spontaneously combustible solids, as well as dangerous when wet solids. So these are all solids. Our liquids are found someplace else. Our liquids may be over here in flammable liquids, or they may be over here in corrosives. These are solids. Okay, so we move on to 5. Category 5 is our oxidizers. These are just our nasty nasties. 5.1 is our oxidizer, and 5.2 is our organic peroxide. Some of the most dangerous things that are out there are these organic peroxides. So they have 2 divisions associated with them. 6 is toxic, and so you can have something that's a solid but maybe creates an inhalation hazard because of the way it's mixed, or it's a liquid and then it creates an inhalation hazard, and that's different than it just is in itself, the way it's being transported, an inhalation hazard. And yes, there's lots of rules dealing with hazardous materials. 6, though, generally we're just looking at biohazards. 7's radioactive. Won't deal with that here. That has its own class, I'm sure. 8 is our corrosives. Both acids and bases are combined together. And then 9 is miscellaneous other material that in shipment may pose a hazard. So one of these is like a chainsaw. So if you have a bunch of chainsaws together, it may pose a hazard, but the chainsaw there in and of itself is not. Okay, lots of rules, but we'll kind of break it down. A, the placard could not be blocked by the direction that it faces. So that, like, the cab of the truck cannot block the placard on the box part of the truck, right? And that it has to have it on the front of the motor vehicle as well as on the front of the vehicle. So on the top of the vehicle and on the top of the motor vehicle as well. It must be securely affixed so it doesn't fall off. And other things should not be next to the placard, such as ladders or other apparatus. And other markings need to be away from it. If there's, let's say, the name of the trucking manufacturer on the back, that needs to be away from the NFPA, the DOT placard. and it's supposed to be on all four sides, and has a solid line border which contrasts the other border. So it has this solid line border, as you see here, a double solid line border, and same thing as you see here with the first, number one category that we're going to discuss, which is explosives. Well, if you're a Mythbuster fan, like our family is, you already know the difference in the different divisions of explosives. This is the largest classification or subdivision of the hazardous materials. But let's just start what an explosive is. And so you got the exploding bomb, and it's orange. And then there's always two different markings. So there's this classification, then a subclassification. So it's a substance, article, or device which is designed to function by explosion, which is an extremely rapid release of gas and heat, or which, by chemical reaction with itself, is able to function in a similar manner, even if it is not designed to function by explosion. So basically, it's able to explode. And so in different ways. And so you have different divisions from 1.1 to 1.6. And so the closer you are to 1, the more hazardous. So 1.1, explosive with mass explosion hazard. So a big radius would be consumed by the explosion. Versus a 1.2, which is when you have a projectile hazard. So you could even think of a pipe bomb. That would be an example of a projectile hazard. Or some of the munitions that the Department of Navy uses have projectiles inside of them. 1.3 is it's explosive, but predominantly it's more of a fire hazard than anything else. And then as we go down, then you can see why we would get into something such as 1.6, which is our fireworks, which are pretty insensitive articles. You would have to feed them with a fuse so that they would detonate. And so the largest commercial application of explosives is in the mining industry. Whether the mine is a surface mine or buried underground, the detonation or deflagration of either high or low explosives in a confined space can be used to liberate a fairly specific subvolume of brittle material in a much larger volume of the same or similar material. That's a mouthful, but it kind of makes sense, right? An explosion, you're able to liberate, so get more material out of the earth. The mining industry tends to use nitrate-based explosives such as emulsions of fuel oil and ammonium nitrate solutions, mixtures of ammonium nitrate prills, which is fertilizer pellets, and fuel oil, ANFO, as well as gelatinous suspensions or slurries of ammonium nitrate and combustible fuels. And there you have classification number 1. So I actually do think it's interesting. It's a lot to say, but a mass explosion is one that affects most the entire load instantaneously. So the entire load is consumed. 1.2, it's a projectile hazard. So not a mass explosion, but something jumps out from it and gets people or things, whatever kind of explosion it may be. And so it's in a 1.3 is there's an explosion, but the fire is intense that follows. It's incendiary, and it takes over. And then we're getting down to 1.4. There's a minor explosion. Pretty much you can contain it to its package. And then 5 and 6 are mostly negligible and insensitive. It should learn to be more sensitive. Bulk explosive site. And we're on to class 2, which is our gases, compressed gases, and there's lots of different varieties of gases. It's easy to get confused, but we'll go over them a number of times so that you understand the differences. So we have two for an inhalation hazard, so that would be a toxic gas. That should say toxic gas. And then you have a flammable gas, you have a non-flammable gas, and then you can also have a corrosive gas. You can have gases that are pure, gases that are, or gases that are mixed. And so hazard class 2 is defined as a gas at 68 degrees Fahrenheit or below, and has a boiling point of 68 degrees Fahrenheit at sea level. And that basically means as soon as you open the container, such as propane, it's just a gas when it comes out, right? Because it's already a gas when it's a liquid under pressure when it's in the container, and as soon as it hits ambient temperature, it turns into a gas. We'll watch a little movie of that. So there's 4 different types of compressed gas divisions, but many markings can apply onto one different kind of bottle. One cylinder, let's call it a cylinder because that's what it is. And something that's important to remember is that just because something's a certain color, it doesn't necessarily mean that, like the green one is a non-flammable gas. Color is not an indication, although you can choose to order colors that indicate what they are to make them easier.
At a southern Georgia coffee shop last week, and this morning we've got security footage of how it all went down. Officials say that a construction crew was digging in the area where they hit a natural gas line. There's the explosion right there on your screen. Officials saying those women are lucky to be alive. The injured women are being treated for severe burns this morning. Remarkably, no one else was hurt in this explosion, but 2 cars and obviously that building was destroyed. But some stunning video this morning, wishing those women a speedy recovery in the hospital.
When a typical cylinder is filled to its design pressure of 2400 psi, it will contain almost 300 cubic feet of atmospheric pressure gas, or about 160 times the internal volume of the cylinder. This compression of gas represents a tremendous amount of stored energy. If the outlet valve is broken off, the sudden release of compressed gas can turn the cylinder into a missile with energy to shoot through a cinder block wall. In one reported incident, a damaged cylinder penetrated 2 sheet metal walls before becoming airborne and exiting through the roof. The tank reached an altitude of 140 feet before falling back through the building's roof a second time. When a steel cylinder becomes a projectile, it can move with great force, at high speeds, and in unpredictable directions, with the potential to cause serious or fatal injuries.
High-pressure gas cylinders have been around for 100 years, and legends of their destructive potential have been around for 99. But could a ruptured tank really burrow through a brick wall? Into the next county.
Here we go, shearing the regulator off the tank. Attempt number 2. In 5, 4, cross your fingers, 3, 2, 1. Yeah! That's the sound! That is a lovely, lovely sound.
The valve has sheared clean off, and that's a very good sign. It looks like the cylinder flew straight and true, but did it have enough thrust to crack the wall?
Oh, God. It was the lard that did it.
At 40 miles per hour, the air tank turned the cinder block to cinders. It even put a fair dent in the wall 6 feet behind it.
Totally.
No way.
I mean, it didn't go all the way through, but it went through this one and it was gone. It's working its way through that one.
I was ready to see this as not possible. I was totally expecting it not to actually work because it's one of those apocryphal tales, and everyone we talked to had heard the story, but no one knew anybody that it happened to.
You know.
We'll cover compressed gas cylinders in more detail later in proper storage for them, as well as the recertification cadence to ensure that they don't rupture because of deposits that can develop inside of the compressed gas cylinders. So this is one of these physical properties that it's really important to remember, that the lower the flash point, so the lower the flash point, the closer the number is to the ambient air temperature, the more volatile. That means the more readily it will catch on fire. Oh, and the lower the flash point, it also means the higher the vapor pressure. So if we look at our hazardous material, we have a liquid, and then we have some vapor pressure up here. And so if I was going to put a match in this, it's the vapor that burns, not the liquid, the vapor. So the higher the vapor pressure, the more that's coming off, the more volatile, as well as the lower the flash point, meaning that I can use something, doesn't need to be a flame to be able to ignite it. So why it's important to know what you